Day 481 of doing a LeetCode problem. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3459, length of longest V-shaped diagonal segment. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, subscribe, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given a 2D integer matrix grid of size n by m, where each element is either a 0, 1, or 2. A V-shaped diagonal segment is defined as the segment starts with 1, the subsequent elements follow this infinite sequence, 2, 0, 2, 0, dot, 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 so it's just repeating 2, 0, 2, 0. The segment starts along a diagonal direction, meaning top left to bottom right to top right to bottom left, or bottom left to top right. Continues the sequence in the same diagonal direction, makes at most one clockwise 90-degree turn to another diagonal direction while maintaining the sequence. Then they give us this nice picture right here showing what diagonals look like. This shows just the diagonal in every direction, and this shows the diagonals if we include this 90-degree clockwise turn. Boom. Then it says, return the length of the longest V-shaped diagonal segment. If no valid segment exists, return 0. All right, y'all. So that may seem a little bit confusing at first. So let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input grid equals a 2D array of integers, or our m by n matrix grid. First array being 2, 2, 1, 2, 2. Second array being 2, 0, 2, 2, 0. Third 2, 0, 1, 1, 0. Then 1, 0, 2, 2, 2, and 2, 0, 0, 2, 2. Now it's important to remember that each one of these arrays right here inside of the initial array represents a different row. So this this right here would be row 1. As you can see, we have 2, 2, 1, 2, 2. So 2, 2, 1, 2, 2. Then the second row, we have 2, 0, 2, 2, 0. 2, 0, 2, 2, 0. Boom. Then third, 2, 0, 1, 1, 0. 2, 0, 1, 1, 0, and so on and so on. So these just represent the rows. We want to, once again, find the longest diagonal segment. In this case, it has an output of 5. It gives us a visual representation right here, right? So this is how the diagonal segment will go, or the longest one. So remember, we have rules to follow. The segment has to start with 1. So boom, it starts with 1 right here. Then it says the subsequent elements must follow this infinite sequence 2, 0, 2, 0. So just after the 1, it should go 2, 0, 2, 0. So as you can see, we have 1, then it goes 2, 0, 2, 0. Now this is an example where we include makes at most one clockwise 90-degree turn. So this has a 90-degree turn right here. Boom. Explanation says the longest V-shaped diagonal segment has a length of 5 and follows these coordinates right here. It makes a 90-degree clockwise turn. Boom. So as you can see, it has a length of 5. 1, 2, 3, 4, 5. Boom. So that's why the output is 5, because it takes up 5 cells, right? It has once again, 1 cell, 2 cell, 3 cell, 4 cell, 5 cells. That's why the output is 5, because that's the longest that we can create. Now it's going to get tricky because we have to remember that we have to follow this sequence. It has to start with the 1, and then it has to go 2, 0, 2, 0 all the way after the 1, right? So we have to find a diagonal that follows that pattern. So just in case that didn't make sense, let's take a look at example 2. In example 2, we have our input grid equals a 2D array of integers, 2, 2, 2, 2, 2, 2, 0, 2, 0, 2, 0, 2, 2, 0, then 2, 0, 1, 1, 0, then 1, 0, 2, 2, 2, and then 2, 0, 0, 2, 2, right? So in this case, it says the longest V-shaped diagonal segment has a length of 4. That's why our output is 4. And these are the coordinates right here. Once again, we're looking at the picture. Once again, it starts at a 1, then it goes to 2, then it makes the 90-degree turn, it goes 0, 2. So it goes 1, 2, 0, 2. Once again, we can't start here at the 0, even though the 0 will still be diagonal. But remember, we have to start with 1. We can't start with 0. So that's why this 0 is not included in our output. And we only have a length of 4. Once again, 1, 2, 3, 4. So finally, let's look at example 3 where there are no 90-degree turns. So in example 3, we have our input grid equals a 2D array of integers. First array being 1, 2, 2, 2, 2. Next array 2, 2, 2, 2, 0. Then 2, 0, 0, 0, 0. Then 0, 0, 0, 2, 2, 2, and 2, 0, 0, 2, 0. Boom. This time our output is 5. Explanation says the longest V-shaped diagonal segment has a length of 5 and follows these coordinates. They show us the coordinates right here in this picture. So we start at 1, so we're starting from the top, remember, because we can't start from 0. So we start from 1, then it goes 2, 0, 2, 0, fits all of the requirements, and there's 1, 2, 3, 4, 5. So that's why our output is 5, because the length is 5. Then we have example 4, where it might get a little tricky, where we just have one grid, or we have one cell that takes up the whole grid, where the grid is the 2D array of integers, and that array is just 1. The output is 1 because the longest V-shaped diagonal segment has a length of 1 and follows these coordinates 0, 0, right? So this cell would just take up it would be the whole grid, so we can include it. That counts. So our output would be 1. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not that difficult to understand at all, so let's get into it. First thing we need to do is we need to get our grid dimensions. So to get our grid dimensions, we're going to say let M equal grid dot count. Boom. And that's going to get us the rows. Then we're going to say comma because we also need to get the columns. So M is going to be the rows. Then we're going to say N, and N is going to be the columns. We're going to say N, excuse me, y'all. We're going to say N equal to grid square bracket 0, come outside the square bracket dot count, and that's going to get us the columns. So now we got the rows and columns. Now we need a direction array for our diagonal moves, right? So we are going to say let directions equal is going to be an array of integers, and it's going to be -1, comma, -1, comma, 1, comma, 1, comma, -1. Boom. So then we need to create a helper function, and we're going to create a depth first search helper function to extend along a diagonal path. So the first thing we are going to do is we're going to come underneath this, and we are going to say func DFS. So it's going to be inside of our main function. Say func DFS, open up the parentheses. We're going to say underscore x colon. That's going to be an integer, and that is going to represent the current grid position. So x and y are going to represent the current grid position. So we need to do y as well. So we're going to say underscore y colon, that's going to be an integer as well. Once again, x, y are going to be our current grid positions. Then we need to declare, we're going to pass in another underscore, then we're going to say direction colon, and direction is going to be which diagonal direction do we want to go. Boom, that's going to be an integer as well, comma. Then we're going to say underscore length colon, that's going to be an integer as well, and that's going to keep track of the current path length that we found so far. Then we're going to say comma underscore turned colon, that's going to be a boolean, and that's going to track whether we have already changed directions once or not. Then we're going to come over here. It's going to return an integer, and we're going to open up the brackets. Boom. So first we're going to stop if we're out of bounds. So we can say if x is less than 0, or two vertical lines for or, x, is greater than or equal to m, two more vertical lines, or y is less than 0, boom, two more vertical lines, or y is greater than or equal to n, then we can open up the brackets and we can just return length, just like that. Now our path must alternate cell values, right? So odd length steps expect cell 2, and even length steps are going to expect cell 0. So we can come underneath this if statement. We're going to start a new if statement, and we're going to say if, open up the parentheses, length, 1 and sign, 1 equals 1. So the bitwise and, then we're going to say 2 and signs, and grid, square bracket x, square bracket y does not equal 2. So exclamation point equals 2, or two vertical lines, or come outside of the parentheses for the or. So outside of parentheses, two vertical lines, we're going to open up some more parentheses, and we're going to say, so or length, 1 and sign, bitwise and 1 equals 0, and 2 and signs, grid, square bracket x, square bracket y does not equal 0, so exclamation point equals 0. Then we're going to come outside of those parentheses and open up the brackets, and we're just going to say return length. Boom. So if it's already turned once, then we must continue straight in the same direction. So we're going to come underneath this, and we're going to say if turned, we're going to open up the brackets, and we're going to say return DFS, open up the parentheses. I'm going to just come underneath this for just to make it easier to read, but still inside the parentheses, we're going to say x plus directions, square bracket, direction, come out, sorry y'all, that is not how you spell direction, direction, boom, come outside of that, and we are going to say comma, then we're going to come underneath that, we're going to say y plus directions, then we're going to say square bracket direction, boom, plus 1, then we're going to come outside of those square brackets, we're going to say comma, then we're going to say come underneath that, direction, comma, come underneath that, length, plus 1, comma, come underneath that, we're going to say turned. Boom. Then we're going to come right here, and we're going to say else. And we're going to open up the brackets. And then, so option 1, we're going to continue straight. And option 2, we're going to change to the next diagonal direction. So we're going to say let next direction equal, open up the parentheses, direction plus 1, come outside of the parentheses, and we're going to say mod 4. Boom. Then we come underneath this, we're going to say return max, we're going to open up the parentheses. Once again, to make it easier, we're going to come underneath this, but still inside the parentheses, we're going to say DFS, open up the parentheses, DFS, open up the parentheses, same thing, we're going to open up the parentheses and come underneath that just to make it easier to read, and we are going to say, we're going to say x plus directions, square bracket, direction, come outside of square bracket, comma, y plus directions, square bracket direction, plus, sorry y'all, plus 1, come outside that, comma. Then we're going to say direction, comma. Then we're going to say length, plus 1, comma, come underneath that, and we're going to say false. Boom. Then come right here. We're going to say comma. We can come underneath it. We're going to call DFS again. Open up the parentheses. Same thing, except this time we're going to say X plus directions. Open up the square bracket. This time we're going to pass in next direction. Boom. Come underneath that. First say comma, then we're going to do the same thing for y plus directions, square bracket, next direction, plus 1, come outside of that, say comma, then we're going to say next direction, come underneath that, we're going to say length, plus 1, comma, come underneath that, and this time we're going to say true. Boom. Now, we are going to come right here, and we are going to, we need to store our maximum diagonal path length that we found, so we're just going to declare a variable for that. We call it RET, say colon, set it as, cast it as an integer, and initialize it at 0 to start. Come underneath that, we're going to say, and we're going to traverse every cell in the grid. So we're going to say for I in 0 dot dot less than m. We're going to open up the brackets. Then we're going to say for j in 0 dot dot less than n. And we're going to open up the brackets. And we're going to start the depth first search only from cells containing 1. So for that, we're going to say if grid square bracket I square bracket j equals 1, then we're going to open up the bracket and we're going to explore all diagonal directions from this starting point. So we're going to say for k in 0 dot dot less than 4, boom, we're going to open up the directions and we are going to say ret, so ret, comma, oh no, not comma, we're going to say ret equals max, then we're going to open up the parentheses. Same thing. We'll just for make it easier to read, we're going to come underneath that, but we're still inside the parentheses. We're going to say RET, comma, come underneath that, DFS, open up the parentheses, same thing, stay inside the parentheses. We're going to say I plus directions, square bracket K, come outside of that, comma, then we're going to say J plus, sorry y'all, should be equal white space, let me fix this, J plus directions, square bracket K plus 1, come underneath that, or first we say comma, then come underneath that K, comma, come underneath that 1, comma, and then we're going to come underneath that and say false. Boom. Then we're just going to come all the way down here, and all we have to do is say return ret. Now that should be all she wrote, y'all. That should be all the code. Let's go ahead and give it a run before we submit it, make sure it works. We got an error already. Oh, sorry, that should not be there, that backslash or forward slash. So now let's run it. Let's run it. Okay, can I find length and scope? We have a typo. Let's run it again. Let's run it. Okay, missing. Let's see. Let me see. Missing. Let's see. Oh, sorry, y'all. Should be a underscore right here. Let's run it again. Okay. Sorry, y'all. Should be an S after this direction. Should be an S right there. Let's see. Let's see. And it's accepted, y'all. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And it's accepted, y'all. 380 milliseconds beats 100% of users. That's what I'm talking about. That's some good numbers right there. So with that being said, y'all, make sure you get one more look at the code. This is the top part. This is top of the middle part. This is the bottom part of the middle part. And this is the rest of the code, y'all. And yeah, with that being said, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.